Hello, my name is Manav, and this is Unit 1, Lesson 3, Solving Multi-Step Inequalities. Just as a review, an inequality is a statement saying that a range of numbers that x can be equal to that makes the statement true. Inequalities are not equations. Now here is a single-step inequality. We are given the number 5x is greater than 20. If you need a reviewer, if the arrow points to the right, it is greater than. If it points to the right and has a line, it is greater than or equal to. Big emphasis on or. If the arrow points to the left, it is less than. And if it points to the left with a line underneath, it is less than or equal to, emphasis on the or. See down here. So our inequality that we're given is 5x is greater than 20. This is asking us what numbers, not number, but multiple numbers can make the statement true that can replace x. So as our answer is here, we see that our answer is x must be greater than 4 to make the equation true. Now here's a little trick we can use. 5 is greater than 4. 5 times 5 is 25, and 25 is greater than 20. True. However, 3 is not greater than 4. But let's see what happens if we were to use the equation normally. 5 times 3 is 15. 15 is not greater than 20. That is not a true equation. And we know that because 3 is not bigger than 4. But 5 is bigger than 4. So using inequalities, you are looking for the values of x that make the statement true. And oftentimes these go from as little to negative infinity, and oftentimes go all the way up to infinity. In Math 1 or Algebra 1, you do not go to the concepts of infinity, you just go to basic numbers. Multi-step inequalities are very simple. They are inequalities that use the same steps that you use as multi-step equations to solve for x. These are the same steps. However, there is an exception. Our exception is when you deal with a negative number in the coefficient spot. If you need another refresher, the coefficient is the number in front of a variable. The constant is a number that is unaffected by the variable. Coefficient has x, constants do not. Let's use this example trying to solve a multi-step inequality using the same steps as multi-step equations. 5x plus 4 is greater than 20. Essentially, in English, 5 times our range of numbers added plus a constant of 4 is greater than 20. Now let's solve like normal. The first step is to isolate x, or get all values that are not connected to x away. So we do the inverse of addition, which is subtraction of this number to both sides. Cross that out, leaving us with 5x is greater than 16. We then do the opposite of multiplication, which is happening here, and we divide 5 from both sides. We can cross out 5 here, leaving us with x equals 16 over 5. Now, how can we check if that's true? A number that is greater than 16 over 5 is 20 over 5, or 4. 5 times 4 is 20. 20 plus 4 is 24. 24 is greater than 20. Now let's practice. First, we deal with the numbers that are farthest away from x. In this case, it's 7. We do the inverse of addition, which is subtraction, to both sides, leaving us with 3x is less than 14. We then do the opposite of multiplication, which is division, to both sides. 3 divided by 3 cancels out, leaving us with x is equal or less than 14 divided by 3. A number that is less than 14 divided by 3 is 12 divided by 3, which is 4. 3 times 4 is 12. 12 plus 7 is 19. 19 is less than 21. That makes this equation true. Let's try this one over here. The first step is to deal with the number farthest away from x. Isolate the variable. The farthest number away from x is 8. The opposite of addition is subtraction, and we do that to both sides, leaving us with 4x is greater than or equal to 6. We then do the opposite of multiplication, which is division, to both sides. We have to do by 4. 4 divided by 4 cancels out. 6 divided by 4 is a fraction. X is greater than or equal to 6 divided by 4. A number that is bigger than 6 divided by 4 is 8 divided by 4, which is equal to 2. 2 times 4 is 8. 8 plus 8 is 16. 16 is greater than or equal to 14. In this instance, greater than. How about this number? 4 over 1 times 6 over 4 plus 8 is equal to 24 over 4 plus 8, which is also equal to 6 plus 8, which is equal to 14. 14 is greater than or equal to 14. Emphasis on this one down here. Now let's go to the exception. Negative numbers in the coefficient. When dealing with negative numbers, make sure to flip the inequality sign, specifically when the negative number is the coefficient. Here is an example. You will see the normal steps that we would normally do in red, and any steps caused by the exception will be done in blue. Our equation is negative 5x plus 5 is greater than 10. The first step is to deal with all the numbers farthest away from x, which would be plus 5. The opposite of addition is subtraction, and we have to get rid of 5 here by subtracting it to both sides. This is what we've been normally doing. Here is the new material. We are left with a new equation. Negative 5x is greater than 5. Because we are multiplying by a negative number, we should be dividing, but currently we are multiplying by a negative number. Because of that, this is going to change. We divide, because as stated earlier, negative 5 is multiplied to x. We divide by negative 5 from both sides, getting rid of negative 5, leaving us with x. We flip the sign, going from greater than to less than, and then we do 5 divided by negative 5, which is equal to negative 1. X is less than negative 1. Now, why does it work like this? A number that is greater than negative 1 is 0. So if we were to do it normally, 0 would fulfill the statement. Negative 5 times 0 is 0. 0 plus 5 is 5. 5 is not greater than 10. So that doesn't make it true. This is false. What about here? A number that is less than negative 1 is negative 2. Negative 5 times negative 2 is 10. 10 plus 5 is 15. 15 is greater than 10. That's why this equation is true. Now try these ones. Using the same method, we must isolate the x, get x by itself on one side. To do this, we must deal with the number farthest away from x, which is positive 27. The opposite of addition is subtraction, and to get rid of a number, we must do the opposite to the same side. We'll rewrite the equation as negative 3x is greater than or equal to negative 12. The next step is to do the opposite of multiplication, which is division, to both sides. And since it's a negative number, we have to change the sign. We divide both sides by negative 3, leaving us with x is less than or equal to 4, because negative 12 divided by negative 3 is equal to 4. Let's try another one. Negative 6x minus 1 is less than or equal to 71. The first step is to deal with all terms farthest away from x, isolating x. We do the opposite of subtraction, which is addition, by this number to remove it from this side and add it to this side, leaving us with negative 6x is less than or equal to 72. Next, we do the opposite, which is multiplication, which is division. The opposite of multiplication is division, which is happening here. We divide both sides by a negative number, causing this to also change. Negative 6 is divided to both sides, leaving us with x is greater than or equal to 72 divided by 6, which is negative 12. And there you have it. This is how you solve multi-step inequalities, including the exception of negative numbers.